In this video, we are going to try to write an algorithm called rolling die, which takes one parameter n, which is a positive integer, and it represents the number of times a die has been rolled. This die that we are talking about has 6 faces numbered 1 to 6, and the return value has to be a string which represents the face and also the number of times the die has landed on that face. For instance, if I say rolling die 10, this means if we roll a die 10 times, this return value tells us that the face which has number 1 has shown 3 times, number 2 2 times, number 3 3 times, number 4 1 time, number 5 no 0, and number 6 1 time. If you add all these numbers, 1 plus 0 is 1, plus 1 is 2, plus 3 is 5, plus 2 is 7, plus 3 is 10, which is the total number of rollings. The same way, if we have this example, meaning 1000 rolls of the die, these are the return values. If you add all these numbers up, meaning 160 plus 171, 159, 167, 172, and 171, it's going to add up to 1000. So we have to write the algorithm to do this one. Here is a good example of introducing a new primitive function. The primitive function is called random AB. It returns a random number between A and B inclusively, meaning that A and B are included. For instance, if I call this and I say 1 and 6, it can return any number between 1 and 6 inclusively. It can return 1, or it can return 6, or 3, or 2, or whatever. This is the main function which is used in creating games, because you need some random number which is going to tell the program how to react. And usually this random number is generated using the system clock on your computer. You can go on Google and search about how the computers are generating random numbers, and you can get more info from there. But let's go ahead and write our algorithm. As usual, the first thing I'm going to do is I'm going to start with the start. Then obviously I need 6 variables, because it can be either 1, 2, 3, the face, representing the face. So I'm going to introduce 1, and initially I'm going to set the variables to be 0. These are the variables that keep track of how many times each of these variables, 1 to 6, represents the face that the die has landed on. So I'm going to copy this one 5 more times. So 1, 2, 3, 4, 5. I'm going to change the numbers to 3, 4, 5, 6. And I'm going to change this one to 2, this one to 3, this one to 4, this one to 5. Apparently I need one more paste here, so I'm going to change this one to 7 and this one to 6. Now, one thing, remember, I told you before, you cannot set the name of a variable to a number. Do not try to set this one to something like this one, 1 equal to 0. You can't. You have to have a variable name that some languages, they even say that it can start with a number. Some languages, they ignore it, but the best one, just to assign something like 1. So all of them are assigned 0 initially. The other thing is that because I have to go through a loop to find n number of random numbers and update these, I need obviously an index. So let's say index is equal to 1. And I'm going to do this one n number of times. Remember, the input is n here. So I'm going to write my loop 9, and I'm going to say if index is less than or equal to n, then 10. The first thing I'm going to do when I go inside the loop, I generate a random number. Remember that we do have this primitive function now. So add this one to the list of primitive that you already know. So I'm going to say, let's use another variable, call it I, to be equal to random 1, 6. So this one is going to generate a random number from 1 to 6 inclusively, which is going to be the face that the die has landed on. Now I'm going to compare this I with 1, 2, 3, and so forth, and update the appropriate variable. So I'm going to say if I is equal to 1, then 12. Then I'm going to say 1 is equal to 1 plus 1. Then I'm going to say and if. So this is for the case that the die has landed on the face which has number 1. So I'm going to copy and paste this one 5 times for the other. So I finished renaming and also changing the numbers. Now when this is done, what we have to do is we have to increment our index, because we have to go and find the next random number. So I'm going to say index is equal to index plus 1, and then I'm going to go and jump to line number. If you go up, the line number is 9, so I'm going to say go to line 9, and now I'm going to end my if, and I'm going to say end if, which is this one, and then at the end I'm going to create a temporary string and then return it. So I'm going to say a string, let's say a variable s, okay, and then I'm going to start formatting the output. So I'm going to say 1, okay, and then let's say I want a space here, then I'm going to say plus, and I want the number 1 here, the number of times it has landed on the face which has a 1 on it. Then I'm going to say plus, I'm going to put space, or I'm going to put a comma, space, and then I'm going to say 2, and then plus 2. Now this one I can just copy this plus sign up to 2 and then paste it again and change the text. So I need 4 more paste. So this is 1, 2, 3, 4, 5. I doubt that I need 5, but let's see. So 2, this is 3. Let's change this one to 3. Let's change this one to 4. This one to 4. This one to 5. This one to 5. And this one to 6. And this one to 6. And I don't need the last one here. and that one is going to be formatted output the way that we want it. So the last thing, we are going to return this s. So we are going to say return s, and we are going to finish the algorithm. This probably was the longest algorithm we wrote, but based on this one, I'm going to create our app in Thunkable, and we're going to have different version of the app because this can be done differently when we want to implement it in our app. And I'm going to introduce new blocks while I'm teaching you how to do this one differently, easier, and very, very short code to accomplish this one. Now, with regard to testing, really, we cannot do the testing here because this is a random number generator and I cannot randomly generate a number here, except the code is so simple. I mean, there is no need to do the testing here. For instance, if this generates 1, then I'm adding 1 to my variable 1, so it becomes 1, and it continues for n number of times.